Okay, lesson 6 is sum and difference identities. So we've learned about the quotient identities, the Pythagorean identities, the basic identities. Now we're going to learn about sum and difference identities. So when you see things being added or things being subtracted. So what this helps you with is if they ask you to figure out the sine of 15 degrees, for instance, because your unit circle is wonderful, it gives you the sine of like 30 degrees, 45 degrees, 60 degrees, 90 degrees, but it doesn't give you the sine of like 15 degrees. So this is where you'll use adding or subtracting other degrees that you do know in order to get the one that you're trying to find. Okay, so this is where it will come in handy. We're going to actually just flip right over to the next page and highlight the important identities that you're going to need to know. And again, you don't have to memorize these. These are all on your formula sheet. These are the addition and subtraction of sine formulas or identities. These is the sum and difference of cosine. And then if you just scroll way down to the bottom of your page, you've also got the addition and subtraction of the tan function as well. Okay, so you don't have to memorize those, but you do have to know how to use them. And you'll find those right on your formula sheet. So let's have a look and see what that would look like. Class example number 1. We have to, oh, actually, no, we're going to jump right over to class example number 2 because this is just asking us to find the tan identity, but they actually give us the tan identity, and it is right on your formula sheet, so we don't have to know how to get it. So just scroll over to the next page. We'll have a look and see how we would figure out the sine of 15 degrees then, using this. Okay, so now they've given us some clues in this question. They said express 15 degrees as a difference of two special angles. That just means two angles that you can get from your unit circle. Okay, so just make yourself a note there. So that means our special angles, we know our 30s, we know our 45s. If we know our 30s, we really know our 60s then, because it's two 30s, right? So the special angles are 30s, our 45s. In other words, our pi over 6s and our pi over 4s, right? Okay. And when it says express it as a difference, what operation is that? These are sums and differences.
Well, I have no idea.
Difference always means you're subtracting.
I was going to guess multiplications.
Nope, that's a product.
Oh, my word.
Okay, so difference is a subtraction. Okay? And then it says, and hence, don't you just love that word? And hence, determine the exact value of sine 15. What does it mean when they say exact value again, guys?
Equal?
Yeah, they want to know what sine 15 equals, but do they want it as a decimal that we're going to round off?
No, it's
Right, we're going to leave it as a fraction, so will have a rational denominator. That means it'll be a fraction, okay? And sometimes it will even involve radicals in the denominator or in the numerator because it will be an exact value. We're not going to round it, okay? And we know how to get rid of the radical in the denominator, right, and make an equivalent fraction, yes. And that's what you would do to put it in simplest form, okay? So let's think about this for a minute. If we want to find the sine of 15 degrees, but on our unit circle we don't have a 15 degrees, but we have 30s, we have 45s, what could we subtract in order to get 15?
30 degrees minus 15 degrees.
Okay, but we don't know 15 degrees. We have to use what we know. Yeah, yeah. So maybe make a note here. Use what you know. And you'll hear me repeat that. Use what you know. You'll hear me repeat that often. And what I mean is use the special angles that you know. Okay, you know 30s, you know 45s, you know 60s then, right? You know 90s then. Okay, so we're going to use really what 15 degrees is then is sine of 45 minus the sine of 30, right? And that's going to give me the sine of 15, right? Now, really I would write this way. That's the sine of 45 degrees minus 30 degrees. Okay? Now, just so that I can use my sine difference of signs identity, I'm going to label this because the sine difference of sign identities is sine A minus B equals sine A cos B minus cos A sine B. And it's really easy to mix up your A's and B's. Okay? So once you have figured out what your sine A and B are, label them. Because then at least if you have them labeled, then when you're plugging them into the equation, it won't be as easy to mix them up. Okay? So this identity is right on your formula sheet. It's the sine of A minus B. See where that is?
Yeah.
Okay, so that is sine A. So that's sine 45. I guess I don't need that bracket. Sine 45 degrees cos B. So that's cos 30 degrees minus cos A. So cos 45 degrees times sine B, sine 30. Okay, so you see why it's, if you have them labeled A and B, you won't make mistakes accidentally putting the wrong one in because it's really easy to do with these. Okay? All right, so now we can use what we know. We can use our unit circle. So what is sine 45 degrees?
Yeah, one of those.
Root
2.
Root 2 over 2. And cos 30 degrees?
Cos 30 degrees, that's root 3 over 2.
Yes, and then we're going to subtract cos 45
Root 2 over 2.
times sine 30,
Root, 1 over 2.
1/2. Yeah. Okay, so root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. Okay, so I'm just going to keep going down. Hopefully you have enough room. When I multiply fractions, I just multiply numerators and denominators. So this is root 6 over 4 minus, and on this side I've got root 2 over 4. Now we have common denominators. That's beautiful, so I can subtract. Okay, but remember with radicals, this does not mean root 4. Root 6 minus root 2 has to just stay root 6 minus root 2. You can't subtract those, okay? And it's all over 4. Okay? Okay? So pretty cool, actually, when it's easy like this and we can find 15 degrees just by subtracting things we know, right? Okay?
So we're going to subtract 15 degrees from a 40.
It's not always as straightforward, and that's what example 3 shows us, actually. Because this one is saying express 5 pi over 12 as a sum of 2 special angles. Okay, well the special angles we know, and let's just think about this for a minute. The special angles we know are 30 degrees, which is pi over what?
6.
Yeah. And 45 degrees, which is, those are our pi over 4s. Yeah. Okay, so we know pi over 6s, we know pi over 4s. This is asking for pi over 12s.
2 times it?
Oh,
45
yes.
times 3.
Yes, exactly. Okay.
108.
So we can use our pi over 6s or our pi over 4s. We just need to figure out how to make them pi over 12s, right? Okay. So 1 pi over 6 would be how many pi's over 12?
2.
Times by 2 on the bottom, times by 2 on the top, 2 pi's over 12. And pi over 4 would be how many pi's over 12?
3.
3 pi over 12. Yeah, okay. So we can use those.
It's a 75 degrees.
Yeah, yeah, exactly. Okay, so now I need to make 5 pi over 12. How am I going to use 2 pi over 12s or 3 pi over 12s to make 5 pi over 12s?
Times it.
Oh, would I times it or just add it?
That's what
I just need one of these and one of these, right? I can add 2 pi over 12 plus 3 pi over 12.
plus 1. Oh, so we have it.
And that is 5 pi over 12, right?
Oh yeah, I'm not looking for 15.
Yeah,
Right.
no, pi over 12. Okay, so now I'm going to just back up here because this is saying express that as a sum of two special angles to show that that equals this. Root 3 minus 1 over root 3 plus 1. Okay? And we're showing that a cotangent of this equals that. Okay? So if we know that these are the two angles we're going to use, a 2 pi over 12 and a 3 pi over 12, okay, we need to do cotangent of 5 pi over 12. The problem is we want to do what we know. On our unit circle, we can't figure out what cotangent of 2 pi over 12 is, or cotangent of 3 pi over 12.
We can find cotangent of how it's
Can we find any cotangents though? Does our unit circle give us cotangents? It gives us tans, yeah, right. We have to use what we know. We know sine, cos, and tan, right? So let's change this then to tan. So we're going to do tan of 5 pi over 12, and then we're going to figure out what that is, and then at the end we're just going to invert it. And that'll give us what cotan would have been, right? So tan of 5 pi over 12 is going to be tan of this one plus this one, right? Which is one of these and one of these, right?
So that's
We want to use what we know. Like we know that 3 pi over 12 is the same thing, but we're going to use this so we can actually read it off of our unit circle. So that's pi over 4 plus pi over 6, okay? Because we can figure out tan of pi over 4 and tan of pi over 6, okay?
That equals.
Yep, it does, because we showed that over here. We did do the work to show that.
or would it be 2 pi, like 2 times pi over 6 and 3 times pi over 4? It's like
Okay, so once you have this, what you have here is a sum of the tangents, right? If you look on your formula sheet for tan of A plus B, like this will be my A, this will be my B, right? And you've got A, tan of A plus B. What is the formula or the identity for that?
For tan,
Tan of A plus B.
it's tan A plus tan B over
Yes,
1 minus tan A times
right. So we've got tan A. See how, again, how important it'll be to have A and B labeled? So you've got tan of pi over 4. Tan A plus tan B plus tan of pi over 6 all over 1 minus tan A tan B, which is tan pi over 4 tan pi over 6. Okay, and again, I say that now this is looking pretty nasty, but we just keep doing what we know. We can use our unit circle to figure out what tan of pi over 4 is.
That's 1.
Yep. And what's tan of pi over 6?
That is pi over 6.
Pi over 6. That's 30 degrees.
Oh. Okay. Found it. That's 3.
Root 3 over
3 over
3. And then on the bottom we've got 1 minus tan of pi over 4 was 1, right? And tan of pi over 6 is root 3 over 3 again. Now I'm going to go back over here to the left side. So what I've really got then on the top is 1 plus, oh, actually let's do that addition on the top. Again, I can't add 1 plus root 3 over 3 without having common denominators. So this is really the same thing as 3 over 3, right? 1 is 3 over 3. So what I've really got on the top is 3 plus root 3 over 3. And then in the bottom, I've got 1 minus 1 times that. So again, 1 times that isn't going to change anything. But this again has to be 3 over 3. So I can go 3 over 3 minus root 3 over 3. So I'm going to have 3 minus root 3 over 3 on the bottom. Okay, everybody with me? See where we got that from? Okay, now again, if I have a fraction divided by a fraction, that means multiply by the reciprocal. You're going to be so good at that, you'll be doing that in your sleep. Times 3 on the top this time, 3 minus root 3 on the bottom. Oh, do you see anything that right away you can see is going to cancel out there?
The 3's.
Aha!
There we go.
That 3 will cancel that 3. And what I'll end up with on the top is 3 plus root 3. And on the bottom, 3 minus root 3.
And then the lowest back, no, actually. 3 minus 3 could be 1.
Still another lesson. That's cool.
Okay, yep. Okay, now this is actually tan of 5 pi over 12. We need cotan in the end, right? So let's flip this so that we get cotan of 5 pi over 12, which is going to be 3 minus root 3 over 3 plus root 3. But again, like Amy said, we don't want to have a radical sign in the bottom, right? So the way that we get rid of that is by timesing by root 3 over root 3. Okay. Now, when we do that, though, we have to remember, guys, we're timesing this whole amount by root 3, so you have to distribute it and make sure you're timesing root 3 by both terms, right? So we've got, I'm going to do it over here, 3 root 3 minus, and then root 3 times root 3 is just 3, all over 3 root 3 minus 3.
Isn't it plus 3?
Oh, sorry, yep, plus 3. Now, do you see a common factor that you could factor out?
Root 3.
You can factor out the 3, right?
Oh.
So you'll be left with root 3 minus 1. And on the bottom, factor out the 3 and you'll be left with root 3 plus 1. And then these 3's do cancel, you're right. And we're left with root 3 minus 1 over root 3 plus 1.
And that's
Which
that.
is what we were trying to prove. So we got there. It got ugly, but we got there using what we know. Do you know what? It's like I said the other day. No, it's going to take practice. It's not the kind of thing that you can just see and go, oh yeah, I can do that, no problem. because it does honestly take the repetition to get good at these. And don't be afraid to muck around in it, because that's what it takes, is really honestly getting uglier before it kind of tidies up. And in the end, when you do actually get what you were going for, it's like, woo! It's the best feeling in the world. It's like you solved the puzzle.
That's it, Red, because I have no room.
I wish that was it, but I do want to show you number 4, because number 4 is really cool and not nearly as hard, I promise.
Right.
Okay, so look at number 4 for a minute. It's just asking us to simplify sine of 100 degrees times cos of 10 degrees minus cos of 100 degrees times sine of 10 degrees. Look at your identities for a minute. Do you see like sine times cos minus cos times sine anywhere?
Yeah.
Yeah. Which one is this?
That's like, it's like,
Yeah, sine of A minus B, right? A subtract. Yeah. So what this means is your 100 is your A, cos must be your B, and then, yeah, this is your A.
Miss Amy Evans, to
This
the
is your
library,
B,
please.
right? Okay. So once you've identified that, what this is really saying is, this is sine A cos B minus cos A sine B. Right? Okay, you with me so far? Okay, and what you just told me a minute ago, that was the identity for sine of A minus B. We found that on our formula sheet. Well, if that's the case, and we know what our A and B is, let's just plug them in there. What was A?
100.
100, so that's the sine of 100 minus the sine minus 10. So really, that's asking for the sine of what?
90.
90 degrees, which we can find on our unit circle. The sine of 90 degrees is 1. Yeah, so see how we can use, yeah, but see how we can use the identities kind of backwards now. When we're given the expression, we can figure out which identity it was, and then sub in our A and B and solve, right? So that's how you simplify them. What about this one? This one is similar. We've got cos of something times cos of that's something, but with a different sign. See, this is a minus, this is a plus. Then we've got sine of that same thing again. So this thing is the same as this thing. And cos and sine are the same, right? Okay, so let's identify where would our A's and B's be then. If this is A, this one will be A, because those two are the same, right? This is going to be B, and this is going to be B. Okay, so look on your formula sheet. Do you see one that is cos A, cos B, minus sine A, sine B? Cos A, cos B, minus sine A, sine B. What is the
That's
cos?
cos A minus.
Is it? Okay, cos A, cos B, minus sine A,
okay.
sine B. It's cos A
plus.
plus B. Yes, yes. Okay, and if it's cos A plus B, then let's sub in then what our A and B is. Cos of A is 1/4 pi minus theta. Plus B, which is 1/4 pi plus theta. Okay, so we need to just kind of tidy this up here. We can put like terms together. So that's the same thing as saying cos of what? What's 1/4 pi plus 1/4 pi? Yeah, half pi, which is pi over 2 is another way of writing half pi, right? And what's negative theta plus theta?
That's nothing.
that's nothing, so it's just 0. So really, we're just looking for the cos of pi over 2. And we can find that on our unit circle. What's the cos of pi over 2? Which is the cos of 90 degrees, in other words.
Oh, that's 0.
0. Yeah. Okay. Class example number 5 is a really, really good question. It says given cos A is 3/5 and cos B is 5/13, where our A lies between 0 and 90 degrees, and our B lies between 270 and 360. Okay, we need to find the exact value of cos A plus B. Well, let's kind of split it first. Let's figure out where these things would lie. Where is cos positive? All suckers take chemistry. Where's cos going to be positive?
Quadrant 3.
No?
Oh, sorry, quadrant 4.
So it could be here or
Could be
A.
A. Either one of those two quadrants. But it does tell us here A is between 0 and pi over 2. So A is in this half of the, right? This is, oh, sorry, this is pi. So, no, that's not.
How would it work?
Yeah, I'm back.
Done with that.
It sometimes works and
Move
sometimes
the lines out
doesn't.
of the way.
Ah.
There we go. Sorry. So no, it's not that whole first half. It's just to there, right? It's telling us it's between 0 and pi over 2. Pi over 2 is up here. Okay, so we know this time we're talking about this quadrant. Okay. I'm just going to tidy this up a little bit so that we can see better without all my scribbles there. Okay, so all suckers take chemistry, and we've identified that cos is going to be in that quadrant. Okay, now it tells us our cos is 3/5. So what is cos? Like thinking of like SOHCAHTOA, what is cos? So
Adjacent over hypotenuse.
adjacent over hypotenuse. Okay, so this would be our adjacent over our hypotenuse. Okay, so we can make a triangle here, remember, just by making a 90-degree angle. Okay, and A would be this little angle in here. So the adjacent side is this side, so that means that's 3. And the hypotenuse is this side, that means that's 5, right? We don't know what our y is. Okay, but the vertical distance would be your y. Okay. Now, how can we figure out then what y is? If this is a right angle triangle, we're going to use Pythagoras' theorem. You're right. Okay, so we've got 3 squared plus y squared, x squared plus y squared should equal 5 squared, our hypotenuse. So 9 plus y squared should equal 25. Y squared should equal, subtract 9 from both sides, 16. So take the square root, so y should equal positive or negative root 16, which is y should equal positive or negative 4, right?
Yeah.
Okay, now is it possible, if this is my y, could y be negative 4? In this quadrant, would my y's be negative? My y's would be positive, so that tells me right away, not negative 4, my y is 4. Okay, because I know what quadrant it's in. Okay. Okay, now let's do the same for the other angle. We know that cos B is 5/13. Okay, so let's think about that for a minute. Here's my all suckers take chemistry. And I know cos is positive. Well, where could cos be positive? Yeah, or Up here, all the trig ratios are positive there. Now, do you have a question?
I was like, how do you know if it's positive or negative or not?
The letter means that.
Just from here. Cos is positive, 5 over 13.
Yeah.
Right? And here, if the C is in this quadrant, this means cos is positive there. This one means all are positive there. So that's how we know cos would be positive here, or it would be positive here because cos, sine, and tan are all positive. Okay? Okay, but again, this tells us that my B is between 3 pi over 2 and 2 pi. Where's 3 pi over 2?
3 pi over 2.
This is 2 pi. This is pi. Halfway to pi would be half of pi, pi over 2, and 3 pi over 2 is down there, isn't it? Okay, so what this is saying is RB, this angle, cos B, is between 3 pi over 2 and 2 pi. So it has to be in this quadrant, right there, okay? Even though technically it could be positive in that quadrant, it's not because of our domain, okay? Okay, so again, we're going to make ourselves a right angle triangle. And again, going back to SOHCAHTOA, this time we're talking about the cos. Oh, cos again is adjacent over hypotenuse. So again, this means 5 is our adjacent side and 13 is our hypotenuse. So we're going to label that. 5 is, here's our little angle B. Our adjacent side is 5. Our hypotenuse is 13. Here's our y value. We don't know what our y value is, so we're going to have to get it from Pythagoras' theorem. So 5 squared x squared plus y squared should equal 13 squared. 25 plus y squared should equal 13 squared, which is 13 times 13. Do you have your calculator there?
139.
1 second.
3 times 10 is 100. 3 times 3 is 30. 3 times 3 is 9. 169.
169, yeah. 169 sound
Yeah.
right? Yeah. Yeah, right.
I've been doing
Okay.
a lot of math.
Y squared should be 169 minus 25, which is 144. So y should be positive or negative the square root of 144, which is the square root of 144?
Your time's shine again.
12. 12 times 12 is 144. Okay, but again, we're going to reject one of these, either the positive 12 or the negative 12. So we have to look in this quadrant. Is it possible here that y would be positive or negative?
Negative.
Y would be negative. So not the positive 12, y is negative 12. Okay, in that quadrant. Okay, now the problem is we have figured out now what our x, our y, and our r is, our hypotenuse. Now it says find the exact value of cos A plus B. Okay, so down at the bottom of our page, we're going to do cos A plus B. Yeah, exactly. Okay, now look again on your formula sheet. What is
A plus B equals cos A times cos B minus sine A sine B.
okay? Problem is, we've been only dealing in coses. How do we figure out sine A and B? Well, that's why we needed to figure out what our y's are, because now we can figure out what our sine is. Okay? Yes, we can. Okay, cos A and cos B, they were given to us up here at the top, right? We have cos A right here, it's 3/5. We have cos B right here, it's 5/13. So we can just plug those right in, okay? Cos A is 3/5. cos B is 5/13 minus, now we need sine A and sine B. Okay, well let's think for a minute. Here's our, this side over here, this was our A, our angle A, okay? So we know that sine is, look back here, opposite over hypotenuse. Okay, now we know our y was 4. Okay, so now we can figure out what sine is. Sine is opposite over hypotenuse. So opposite is 4 over hypotenuse, which is 5. So sine is 4/5. And the same, we can do the same thing then with our B angle. So sine of B would be, if our y is 12, which is what we figured out right here, then we're going to have opposite, which is 12, over our hypotenuse, which is 13. So sine B is 12/13. Okay, now when we multiply fractions, we just multiply numerators and denominators. So we got 15, and 5 times 13 on the bottom is 65. I'll give it to you. Minus 48/65. Oops, I'm sorry. We have something wrong there. 12 was negative 12. Sorry. So this is negative 12/13. That's minus negative 45/65. Sorry. Okay. So that's really 15 plus 48, which is 63/65. Wow. So this question actually combined a lot of different things that we should know, right? We should know and be familiar with SOHCAHTOA. We should know and be familiar with Pythagoras' theorem to find your hypotenuse or any other, your x or y side, right? We should be able to use the identities from our formula sheet and just plug them in. We should be able to multiply fractions and add and subtract fractions. So this is an excellent question, actually. Star that question. Very well could, yes. Okay, and these questions here, for practice, we're going to do 1 to 3, ACE, and alternating like that, and then 4 to 11. Okay, just to get the practice with those ones.